All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to be solving a single variable equation that involves the multiplication and division of fractions. So we're taking a look at the problem. We are given that negative 3 and 4/15ths x is equal to 8 and 23/40ths. And we have to find out what x is, okay? So what is our first step? Our first step is to convert these mixed fractions into improper fractions. This is going to involve a little bit of thinking and multiplication, but we can do it. What we do is we multiply the denominator by the whole number and we add the numerator. I'll say it again. We multiply the denominator by the whole number and we add the numerator. We ignore this sign while we're doing that, and then we just slap the sign back on at the end. So what is 15 times 3? Okay. If you didn't know off the top of your head, you could just do this. It's a very simple multiplication. 15 times 3. 5 times 3 is 15. Carry the 1. 1 times 3 is 3 plus 1 is 4. So 15 times 3 is 45. Now you take that and you add 4. 45 plus 4 is 49. Right? So you've now converted negative 3 and 4/15ths to negative 49/15ths. Just like that, x, okay, negative 49/15ths is being multiplied by x. We just don't write the multiplication, but you can do that if it helps you. Equals 8 and 23/40ths. We've got to convert this into an improper fraction. First, we have to multiply 40 by 8. Okay, the way I tell students to do this is to think, what is 4 times 8? Well, that's 32. Just add a 0. That's 320. Now we have to add 320 to 23. Okay, and it could help to stack add this. 0 plus 3 is 3. 2 plus 2 is 4. 3 plus 0 is 3. So 320 plus 23 is 343. And what we write is 8 and 23/40ths is equal to 320. I said 320. I meant 343 is equal to 343/40ths. Okay? Now what? Well, now we have to, what my students do is they call this keep, flip, change. So in order, what we want to do is divide both sides by negative 49/15ths. Here's how that looks. We're actually going to divide out, okay, of both sides, negative 49/15ths. So we might as well write it, negative 49 over 15, and over here, negative 49 over 15. Okay? But this isn't very helpful, right? Because this just looks like a huge mess. So what we do is we flip 49 over 15 to negative 49 over 15 to negative 15 over 49. And we multiply that reciprocal fraction by the original fraction. So we're going to put a multiplication symbol here and a multiplication symbol here, because what we do on the left, we must do on the right. So the effective calculation when we divide out negative 49/15ths is to multiply both sides by negative 15 over 49. That's the effective calculation. So we'll multiply both sides by negative 15 over 49. Okay, so here's the fun part. On the left side of the equation, this 15 cancels with this 15, and this 49 cancels with this 49, and a negative times a negative is a positive 1, right? Negative times a negative is a positive. So the only thing that's left on the left side of the equation is just x. Okay, x equals. And now we actually have to do some math. We have to multiply across the top and across the bottom. But we don't want to do that. We don't want to do that because that's a lot of work, right? So if possibly, we want to simplify what we have to do. But first, let's write what we have to do. We have got to multiply 343 over 40 by negative 15 over 49. Okay? So, but I want us to stop and pause and think about what we could do. What we could do is we could simplify this a lot, right? And let's make sure about just what we can do. First, we need to factor 343. Okay? Now, let's do that slowly. First, we know it's not 2 as the first prime factor because this is an odd number. We'll try 3 next. If these add up to something divisible by 3, then we can divide by 3. 3 plus 4 is 7. Okay? 7 plus 3 is 10. 10 is not divisible by 3, so 3 is not a factor of 343. It's not 4, and it's not because it's odd, and it's not 5 because this is not a 0 or a 5. It's a 3. It's not 6 because there's no multiple of 6 that ends in a 3, and so we have to think about 7. Is 343 divisible by 7? Well, the only way we can do that is to test. Now, there is a trick, but I personally think the trick is more complex than just dividing. So we'll try to divide 343 by 7, and we'll see what we get. A lot of times you are just experimenting with the problem. So how many times does 7 go into 34? Well, 7 goes into 34 4 times. Put that 4 right here. Okay? 4 times 7 is 28. And now we subtract 28 from 34. Okay, so 34 minus 28. We got to borrow from the 3. This becomes a 2. This becomes a 14. 14 minus 8 is 6. And then 2 minus 2 is 0. So now we bring down the 3. How many times does 7 go into 63? Exactly 9 times. So it turns out 7 was a perfect factor of 343, and its factor pair is 49. Okay? So I want to stop there right there, and I want to point something out. 343 is equal to 7 times 49. All right? So what I want to do is rewrite this, and I'm going to replace 343 with the product of these factors right here. So check this out. I'm going to rewrite x equals, and then I'm going to write 7 times 49. Okay? Because what I'm trying to do here is get you to think about canceling these 49s out. 7 times 49 over 40 times negative 15 over 49. Now let me show you something cool, because when students were working on this in class, they were coming up with these massive 5 or 6 digit numbers, and there's just no need for that, because right here, because everything is being multiplied, I can cancel these 49s. They're gone now. So let's rewrite and see how we've simplified the problem. I will rewrite x is equal to 7 times negative 15, okay, over 40 right here. And the 15 is just over 1 because we've canceled the 49, leaving behind a 1 in its place. Well, this is a much easier problem, but what if I told you that it could get even easier? Look at 40 and negative 15. Okay, 15 and 40 have common factors, and the largest of those common factors is 5. All right, so what if we divide the 40 by 5, and we divide the negative 15 by 5? What would we get? Well, let's find out. So, because I'm doing the same thing to the top and the bottom, it's okay for me to do this. So now I'll rewrite x is equal to 7 times, and now what is negative 15 divided by 5? It's negative 3. 7 times negative 3 over, okay, what is 40 divided by 5? It's 8, okay? So now we have a much simpler problem. There's nothing left to reduce. We just have to multiply across. So 7 times negative 3 is negative 21. And that's over 8. So I want us to look at what we did. Using nothing but factoring, we solved this problem, right? Now, we're not done because we're going to turn this into a mixed fraction. Just to be clear, 21's factors are 7 and 3. those are both prime numbers. Okay, 8's factors are 2, 2, and 2. So there's no common factors here. We can just turn it into a mixed fraction by asking how many times will 8 go into 21? It goes in twice. And then how many are left over? Well, if you're having trouble doing that in your head, you can just go up here to your side work area and divide 21 by 8. Okay, 8 goes into 21 2 times. 2 times 8 is 16. And then we can do the subtraction. 11 minus 6 is 5. And 1 minus 1 is 0. So here's how you write the fraction. When you see this, you put the quotient that you get as the whole number. So this is 2. And then you put the remainder as the numerator. And then you put the divisor as the denominator. And remember, this was negative, so we put negative 2 and 5/8. Okay, this is negative 2 and 5/8 right here. That is what x equals. X equals negative 21 over 8, which is equal to negative 2 and 5/8. So there was no need for a calculator or a whole bunch of huge number computations, but you had to think strategically. You had to think about prime factors. I've been hammering this from the very beginning. Prime factorization and factorization in general, and just thinking about numbers as constituents of one another, of smaller numbers being multiplied together, that is going to make your life so much easier in mathematics as you go forward. Now, we should check this. So we think x is equal to negative 21 over 8, which is equal to negative 2 and 5/8. All right, so let's go back to the problem. We claimed that negative 3 and 4/15 times x equals 8 and 23 over 40. Okay, that's what we claimed. So it would be good to substitute back in here negative 21 over 8 or negative 2 and 5/8 to see if in fact these two things are equal. So here's what we're going to do. We're going to check the answer. We're going to go down here and put check. Okay. And the very first thing I'm going to do is rewrite the problem so we can all see it. And that's negative 3 and 4/15. So the question is, does negative 3 and 4/15 times negative 2 and 5/8 equal 8 and 23 over 40. Okay, so 8 and 23 fortieths. Right, that's what we want to know. Is this an equivalence that's true? So in order to find that out, we actually have to multiply these two fractions together, and then we have to figure out what the common denominator is and see if they all equal one another. So the very first thing to do is convert all three of these numbers from mixed fraction into improper fraction. Good news is we already did it. So up here, we converted negative 3 and 4/15 into negative 49 over 15. So I'll just go down to a new line and write negative 49 over 15. Okay, times, what is negative 2 and 5/8? Well, we found it right here. It was negative 21 over 8. Negative 21 over 8. Okay, equals, question mark, we want to know. And then 8 and 23 fortieths was converted into 343 over 40. So over here, I'll write 343 over 40. Okay, so we have to multiply across the top and across the bottom. But you know me, I don't want to do any more work than I have to. So I'm going to, I notice I've got common factors with 21 and 15, and that common factor is 3. I can actually simplify my life a little bit by dividing out, okay, of both of these on top and bottom. That's the only reason it's okay. I can divide out of 3. I'm just making a little note that I'm going to divide 21 by 3, and I'm going to divide 15 by 3. Let's go back to the problem. We'll keep the negative 49 for the time being. Make sure you can see everything. Negative 49, okay, over whatever 15 divided by 3 is, that's 5, times 21 divided by 3 is 7, over 8. Right? I like that. It's much easier to work with this now. So the question is, what is 49 times 7? Well, here's how we can do that. We can ask the question, and we can just find the answer by multiplying 49 times 7. Okay? Now, those of you who are paying attention will find this familiar ring. Look right here. We already found out that 7 times 49 equals 343 because we divided 343 by 7 to get 49. So when I do 49 times 7, I'm really repeating work. So 9 times 7 is 63, carry the 6. 4 times 7 is 28, plus 6 is 34, so 343. All right, let's go back down here. I'm going to say, does this equal 343 over 40? Okay, one last step. What we do is we replace negative 49 times 7 with negative 343 over 40. 5 times 8 is 40. And I just noticed a little tiny mistake I made, but it's okay. Does this equal to 343 over 40? No, it's not, because there's a negative sign right here. And that just made me remember a little bit of a mistake that I made, okay? And here's the mistake that I made. When I divided 21 by 3 and I got 7, did you notice what I dropped the negative sign? That happens all the time. So we got to bring that negative sign back in. I didn't do that intentionally to confuse you. That was my mistake. But that's a mistake that happens all the time. Now, what does that mean effectively? When we multiplied 49 by 7, right, we said negative 49 by 7, we said that equaled negative 343. Now we're multiplying negative 49 by negative 7, and all that has the effect of doing is making the resulting product positive. So I can just get rid of that. And now the world works again. And that actually is a perfect case study in why we do the checks, okay? Because it really makes you stop and think. The bottom thing, the very last thing, these things have to equal each other perfectly in order for you to give the coveted double check, all right? So right there is a perfect demonstration. It helps you find your errors. When you get down to this and you're not finding an equivalence, you have to go back and find, oops, I made a little error there. Right? This negative sign got dropped, so I just add it back and recompute, and I get the answers are equivalent. So that means that this is our solution right here. And we can put double check marks because we checked it. Okay? So this is our solution. We go back up. Here is what we were given. And here is our side work. And once again, just to reemphasize, the orientation and layout of this paper is nice and neat. All the X's are lined up, okay? The solution and the check are lined up. Everything is nice and neat so that a teacher or a student like you or a peer, you could hand this to one of your friends and say, here's how I solved it. And you would be able to go back and reconstruct your own thought processes. You know, so that is the answer to that problem. I hope this video was useful to you. If it was, please give the video a thumbs up. This indicates to me that I'm doing good work for you. You know, I suppose if you hated the video, give it a thumbs down. I mean, or if it didn't help you, right? And also, please leave a question in the comment section if you have one. And if you have not already, please subscribe to the channel and click that notification bell so you are always alerted to new videos on this channel. Thank you.